Hello, Fact Fanatics, and welcome back to G Fun Facts Online. Get ready to have your minds blown, because today we're digging deep, literally deep underground, to uncover a secret that could reshape our energy future. What if I told you those dark, abandoned mines, relics of our industrial past, are holding a key to clean, reliable heating for our homes and businesses? Sounds like science fiction, right? But it's very real, and it's called mine water geothermal energy. Imagine this. When coal mines or other mines are abandoned, they often fill up with water. And deep underground, the earth is constantly giving off heat, like a giant natural radiator. This water gets warmed up, maintaining a surprisingly stable temperature all year round, typically between 10 to 20 degrees Celsius, sometimes even hitting 40 degrees Celsius about a kilometer down. This isn't just any water. It's a massive, naturally heated reservoir, a low-carbon energy source just waiting for us to tap into it. It's a brilliant mix of our industrial history and super smart green technology. So how do we actually get this warmth from the depths into our living rooms? The science is beautifully simple. First, we draw this geothermally heated water up from the flooded mine, maybe using old shafts or new boreholes. Then, at the surface, this mine water flows through a device called a heat exchanger. Think of it as a clever go-between. It transfers the heat from the mine water to a separate clean water system that then circulates through buildings. So the actual mine water, which might not be super clean, usually doesn't come into your house. And now for the real magic, heat pumps. These incredible devices take that relatively low-grade heat, say 15 degrees Celsius, and efficiently upgrade it to much higher temperatures, like 50 to 70 degrees Celsius. That's perfect for heating our spaces and giving us hot water. And get this, for every 1 unit of electricity a heat pump uses, it can deliver 3 to 5 units of heat. Talk about efficiency. Once the heat is upgraded, it's distributed to homes, businesses, or even entire district heating networks. And what happens to the now cooler mine water? It's usually sent back underground to the mine, where it gradually reheats. It's a sustainable, circular system. There are mainly two types. Open loop, where mine water is directly used in the heat exchanger, often more efficient, but needs decent water quality. And closed loop, where pipes with a special fluid are sunk into the mine water to absorb heat, protecting equipment from potentially yucky water, though it can be a tad less efficient. Now let's talk about the sheer scale of this buried treasure. It's mind-boggling. In the UK alone, it's estimated that a whopping 25% of all homes and businesses are sitting right on top of former coal mines. The UK Coal Authority reckons these mines could hold enough geothermal energy to heat every single home on those coal fields. Across the pond in the US, the Department of Energy estimates that thousands of former coal mine sites could be repurposed, potentially powering nearly 30 million homes. And Scotland's Midland Valley? It's estimated to hold nearly 8,000 petajoules of untapped heat from its disused mines that could meet 40% of Glasgow's heating needs. But it's not just about the energy. Repurposing these sites also tackles big environmental headaches. Abandoned mines can sometimes pollute water and be safety hazards. Turning them into geothermal sources transforms these liabilities into valuable assets, helping to heal the land. So, what are the rewards? They are huge. Environmentally, this is a champion. It drastically cuts our reliance on fossil fuels for heating, slashing greenhouse gas emissions by up to 75% in some projects. It's renewable, sustainable, and can even help clean up polluted mine water. Economically, it's a powerhouse. Once up and running, these systems can offer much lower and more stable energy prices compared to unpredictable fossil fuels. We're talking potential heating cost reductions of up to 67%. Plus, it creates jobs in drilling, construction, and maintenance, often in communities that really need economic boosts. Imagine revitalizing old mining towns with this new purpose. Some investments even pay back in as little as 5 years. Socially and strategically, it means greater energy security because it's a local resource, reducing dependence on imported fuels. It improves community well-being with affordable warmth and by transforming industrial scars. And it's versatile. This stable temperature water can also be used for cooling in summer, or for things like fish farming or heating greenhouses. Technically, it's super reliable. Unlike solar or wind that depend on the weather, Geothermal energy from mine water is there 24/7, 365 days a year. And the technology, heat pumps, heat exchangers, it's all well established and constantly improving. Of course, it's not all a walk in the park. There are challenges. The initial setup costs for checking the site, drilling, and installation can be pretty high. The mine water itself can sometimes be corrosive or full of minerals that could clog pipes, so you need smart design and the right materials. You also need detailed studies to confirm there's enough hot water and that it flows well. And the mine needs to be reasonably close to where the heat is needed. Clear rules, government support, and public awareness are also super important to get these projects off the ground. But despite these hurdles, amazing projects are already proving this works. In Heerlen, Netherlands, they've been using abandoned coal mines for a massive heating and cooling network since 2008. In Gateshead, in the UK, a new mine water heat network is supplying heat to council buildings, a college, an art center, offices, and hundreds of homes, saving tons of CO2. Siam Garden Village, also in the UK, plans to heat 1,500 new homes this way. Mears in Spain heats a hospital and university buildings. Bochum in Germany is even researching how to store solar heat in old mines. And the US is showing growing interest, with projects and funding on the rise. These examples show it's not just theory, it's delivering real benefits. So what does the future hold for mine water geothermal? It looks incredibly bright. We're seeing constant innovation in technology, making everything more efficient. A really exciting idea is using these vast underground mine networks as giant thermal batteries, storing excess heat from other renewable sources like solar, and then using it when needed. Imagine how that could help balance our energy grid. We'll also see more integrated systems, maybe solar panels powering the heat pumps to make it even greener. And don't forget cooling. That consistent mine water temperature is great for air conditioning too. With growing support from governments and more investment, this is set to take off. It's the circular economy in action, turning old, derelict mines into a source of clean energy and revitalizing communities. We could soon see it used more in farming, for greenhouses, or in industries needing low-grade heat. Mine water geothermal energy is a powerful opportunity to transform symbols of a bygone industrial era into shining beacons of a sustainable future. By cleverly tapping into the Earth's natural warmth, held within these forgotten underground networks, we can unlock a clean, reliable, and affordable heating solution. As we all strive to decarbonize and build stronger communities, the silent, warm waters beneath our old mining towns offer a truly compelling path forward. It's a testament to human ingenuity and a promise of a warmer, greener tomorrow. That's all for today on G Fun Facts Online. Thanks for tuning in, and remember to stay curious.